In this lesson, we're going to be simplifying radical solutions. Our objectives are to make sure that we can simplify square roots, know that the square root of -1 is I, the imaginary number, and lastly, we're going to solve equations of the form x squared equals k. All right, before we start, it's important to just bring our various perfect squares to mind. So 1 squared is 1, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9 squared, and 10 squared. These numbers should be on our mind as we work through the next few problems. All right, so what we're going to be doing here is simplifying radicals. None of these are perfect squares, but they have factors that are perfect squares. So when I look at 8, I think, oh, well, 8 is the same as 4 times 2. And with square roots,
when I have multiplication, I can take the square root of one part and leave the other in the radical. So when I take the square root of 4, I get a 2 outside, but this 2 stays inside. So square root of 8 can be rewritten as 2 root 2. 28 also has 4 as a factor. We can write that as 4 times 7. So our answer, square root of 4, is 2, and the 7 remains inside. When we get down to square root of 27, we're going to have the perfect square 9. 9 times 3. Square root of 9 is 3, and we have a 3 left inside. All right, I would encourage you to try these before I go over these. All right, welcome back. Square root of 45, we're going to have 9 times 5, which equals 3 root 5. Square root of 160. Now, if I'm clever, I see that 16, the perfect square, is there. So 16 times 10 gives me the simplified answer right away of 4 root 10. But it's not unusual for people to go this route. So let me show you another solution. You might have done 4 times 40 and said, hey, 4 is a perfect square, and then you'd have 2 root 40. The only problem there is 4 also goes into 40. So then you could do 2 times the square root of 4 times 10, which gives you 2. Square root of 4 is 2 root 10. And then when you multiply this out, you get the same answer I had above, just it took a few more steps. Square root of 700, the big perfect square in there is 100. 100 times 7, square root of 100 is 10, root 7. All right, now we're going to move on to I. The square root of -1 is defined to be I. Now this may seem like a made-up mathematical concept, but I do want to assure you that it has applications in fields like electrical engineering and computer graphics. For our purposes, we're just going to use it to simplify answers. So when we look at this first one, we're going to split up the square root of -9 into the square root of 9 times -1. The square root of 9 is 3, and we just learned that the square root of -1 is I. Same thing here. We can think of square root of -36 as 36 times -1, so our answer is 6I. When we have a problem like before, and I'll just write the -1 first, and then I remember that 12 is 4 times 3. So the square root of -1 is I. Square root of 4 is 2. We usually write that out front, so I'm going to write that here. Square root of 3 is root 3, and so we can rewrite square root of -12 as 2I root 3. All right, now we're going to be solving equations by undoing a square. And to undo a square, we're basically taking the square root, but we need to understand that we have two solutions, because I could square +5 and get 25, but I could also square -5 and get 25. So when I solve x squared equals 25, I have two answers, x equals plus or minus 5. All right, so we've got 4 of them to do here. So here, square root of 81 is 9. Remember, we have two answers, plus or minus 9. This one, of course, is that negative again, so x is going to equal plus or minus. Square root of 49 is 7. Square root of that negative is I. So we get plus or minus 7I. Negative 12 should look familiar, but we'll take an extra step. So we'll do x equals plus or minus the square root of -12, and And we can write out like we did before. Let's see, negative 12 is negative 1 times 4 times 3. So x equals plus or minus, let's see, the 4 square root is 2, the negative 1 is I, and then I have root 3. 27, it's also the same idea, x equals plus or minus square root of 27, which I know is the same as 9 times 3, so x equals plus or minus 3 root 3. All right, so now we're just going to go one step farther. Same process. We're going to take the square root of both sides and we're going to have a plus or minus. So start with this one. X plus 2 equals plus or minus 3. So when we take the square root of 9, we get 3, and we have two options. Now we're going to subtract 2 from both sides. So x equals, and we have to do this, positive 3 minus 2 is my first answer, and negative 3 minus 2 is my second answer. So I get 1 and negative 5, two answers. All right, let's try the same thing over here. 3x plus 2 equals, this time I'm taking the square root of negative 36, so that's 6i. Remember, I have two answers, plus or minus. My next step is to subtract 2 from both sides, so 3x equals plus or minus 6i minus 2. And my last step is to divide by 3. So x equals plus or minus 6i minus 2 all over 3. Now I can leave my answer like that. I should point out up here, we can't combine these. This is an imaginary term and this is a real term, so they're not like terms that can be combined. I can divide each by 3. You could write your answer plus or minus 2i minus 2/3, but that's as far as you could go. So either answer is fine. You can leave it like this, or you can leave it like this. They're both good answers. All right, so we've got two last problems here. In this one, square root of both sides, 2x plus 1 equals plus or minus, and we've got the square root of 8. This one's not a perfect square, so square root of 8, remember 8 is 4 times 2. So that means 2x plus 1 equals plus or minus 2 root 2. I'm going to subtract 1. So 2x equals plus or minus 2 root 2 minus 1. And then I divide by 2. So plus or minus 2 root 2 minus 1 all over 2. Again, that answer is fine. I can simplify it if I want to. I could go another step and divide both terms by 2. Plus or minus root 2 minus 1/2 is another good way to write our answer. All right, one last problem here. We've got 6x minus 5 equals plus or minus, and we've got the square root of negative 5. I'll just write that as negative 1 times 5. So that gives us 6x minus 5 equals, square root of negative 1 is I, so plus or minus I, but that 5 stays inside because it's not a perfect square. I'm going to add 5, so 6x equals 5 plus or minus I root 5. And my last step is to just divide by 6. So 5 over 6, oops, 5 over 6 plus or minus I root 5 over 6. All right, you should have enough to be able to do that next homework assignment number 6.